Here's some help with number 6 and 7 from your quiz. So number 6, you could use the quotient rule, but in section 3.1 we really hadn't learned the quotient rule yet. So I'm going to show you how we can rewrite this problem as a single polynomial. So you guys know the cube root of v you can write as v to the 1/3 power. And then I'm going to write minus 2v e to the v. Okay, now, do you guys remember, if you have a v on the denominator, that really is like saying v to the -1 power. So what we can do is we can bring that up with the rest of this, but we'd have to distribute it. So we would distribute by v to the -1. Remember, when you multiply, you add exponents. So I would do one more step of f to the v by distributing this to both terms, and then you should be able to take the derivative pretty simply. Okay, so that's help with number 6. For number 7, we have this equation, y equals x plus 2 over x, and we're supposed to find the tangent line at the point 2, 3. So it might be nice just to go to Desmos and graph it, and what you're going to notice, it kind of looks like, it's not a parabola, but it kind of looks like this, and then there's also a section kind of down here like that. So this is kind of what the graph looks like. And what we're trying to find is at the point 2, 3, we are trying to find the tangent line. Okay, so the first thing that you want to find is the slope. Remember, when you take the derivative, that helps you find the slope. So I would rewrite this function, first of all, as 2x to the -1. Does that make sense? And then go ahead and take the derivative of that. Once you have the derivative, what you want to do is plug in a 2. So once you have a derivative, plug in 2 for x, and then you will have your slope. So plug in 2 for x, and then you will have your slope. Once you know your slope, and you know a point, you should be able to do the point slope form, which is y minus y1 times the slope, or slope times x minus x1, and you're going to plug in the coordinate 2, 3. So it'll be y minus 3 equals whatever your slope number is, times x minus 2, and then you're going to have the equation of this line. You're also asked to find what's called the normal line. The normal line is the line that's perpendicular at that given point. So if you guys remember from Algebra 1, if you have a slope of, let's say, 1/4, the perpendicular slope is opposite reciprocal. It'd be -4. So once you know the slope of the blue line, you can do the opposite reciprocal to find the slope of the green line, and then you can do the point slope form again, but with your new slope. And what you should end up with is the tangent line and the normal line. And if you guys can, you're going to sketch a graph really similar to what I have right here and check it on Desmos also. So good luck with that problem. If you still have questions, let me know. But again, I think the hardest part is once you find the derivative, all you do is plug in a 2, and your slope is going to be an actual, just a number. This is going to be just a number once you plug in 2 and for your derivative.